Hi guys, and welcome to our video where I'm going to be carrying out a review and showing you the basic setup of the Geeetech A10m printer. In addition to this, I'll be showing you the upgrades and telling you why I've made these upgrades. Please remember to like our video if you find it useful and subscribe to our channel, as it really does help us to grow. So starting off with the specifications of this printer, it is an FDM style material extrusion 3D printer. Now if you'd like to know more about different types of 3D printing, click the link in the video in the description below, where there will be a video where I will describe the 7 different recognised categories of additive manufacturing. So this Geeetech A10m is a Cartesian style 3D printer where the hot end will move in the X and Z axis, this being the X axis and Z axis being moving up, and the build plate will move in the Y axis. The build volume of the printer is 220 millimeters in the Y-axis, 220 millimeters in the X-axis, and 260 millimeters in the Z-axis. The printer is a 2-in, 1-out, so as you can see at the top, we've got 2 different PLA spools. It goes in through the Bowden tube, and it's got 1 hot end nozzle, which you should see a picture of now on the screen. The price of the printer starts from around about £240. To set up your printer, I would recommend following the following sequence as it worked best for me. First of all, I would calibrate your steps per millimeter for each stepper motor. Now each stepper motor works by moving in increment steps, so it's important to calibrate the number of steps the stepper motor needs to move in order to move 1 millimeter. To do this, you need to do this for your X, Y and Z axes and your extruder motors. So to do it for your X-axis, first you should home the X-axis and mark where I have marked here where it is homed. Then go into your printer menu. So for the Geeetech A10m, you go into the menu, go into prepare, go into move axis, move the X-axis, and then you move it by 100 millimeters. Then you will mark where it is moved to, and then go back to home it. Then you need to measure 100 millimeters and see what the difference is between the measured 100 millimeters and where it is moved to. Then using the equation, which is now on the screen, where you will divide the measured 100 millimeters by the measured distance that the actual extruder moved, and then multiply this by your E steps per millimeter. This will give you your calibrated E steps per millimeter to ensure that your X-axis will now move 100 millimeters when you ask it to. In order to find your current E steps per millimeter, you will go into the menu, go into control, go into motion, and scroll down until you find E steps per millimeter. In here, you will find the different E steps per millimeter for your X-axis, your Y-axis, your Z-axis, and your extruder. Note here that the extruder only has 1 value, even though as you can see there are 2 extruders, as this value is shared across both extruders. After you've done this for the X-axis, you should repeat these steps for your Y and Z-axis. However, to do it for your extruder, a slightly different method is needed. In order to calibrate the E steps per millimeter for your extruder, I would recommend cutting off a piece of PLA and marking out 100 millimeters on it, as I have done here. Then, to remove one spool, doesn't matter which side, as we said before, the value is shared across both extruders, and to put in the marked PLA until the first mark is at the start of the extruder. And then to go into your menu, prepare, move axis, move the extruder, and move it by 100 millimeters. You should note that although you're doing it dry and not feeding it through the nozzle for the first time, you need to get the nozzle up to temperature, as the printer doesn't know this. Once you've extruded it out through the 100 millimeters, you should mark where it's up to and repeat the steps where you measure where it's up to compared to the 100 millimeters and use the equation before to calculate your new E steps per millimeter value. Once you put in your new E steps per millimeter value, you should store these settings by going into the menu, control, and then store the settings. Then you should verify that this new E steps per millimeter value does go 100 millimeters. After you've done this, however, I would recommend repeating these steps, but with the filament going through the nozzle. The reasons for this being there is extra friction required when doing it through the nozzle, such as the weight of pulling the filament off the spool, the friction of feeding the filament through the Bowden tube, and the pressure feeding the filament through the nozzle. To do this, I would recommend marking the 100 millimeters on the spool and repeating the steps. Now that you've calibrated your stepper motors, we need to level the bed. In order to do this, I would get a piece of paper and download the Thingiverse file for the bed leveling, which I put in the description below. First of all, with your piece of paper, you need to fold it in half so that the paper is 2 thicknesses. Then go into the menu and click bed leveling under the prepare option. Then we need to put the paper underneath the nozzle as it moves to each of the 4 corners. You should adjust the height of the bed using the leveling knobs underneath. Here it is important that you take note which way to spin the knobs in order to raise and lower the bed. Once you've done this, putting the paper under the nozzle, you should adjust the height of the bed in one corner until there is a slight amount of drag. If there is no drag between the bed and the nozzle, then the bed is too low, and if there is a lot of drag, then the bed is too high. Once you've done this for one corner, click on the screen next corner and repeat for each of the 4 corners. You should do this twice for each corner, as when you adjust one corner, it will slightly adjust the height of the previous corner. Once you've done this with the paper, you should slice the file which you've downloaded from Thingiverse in your chosen slicer. I personally use Ultimaker Cura, and do this with a skirt, as the skirt will also help you to level the bed. While you're printing this part, you should then adjust the bed as it's printing. If the bed is too close, then it will be a very thin layer, and if the bed is not close enough, then the part won't adhere to the bed. You should adjust this as it prints. There should now be a picture on the screen of what mine looks like. Now that you've got a level bed and you've calibrated your stepper motors, we can get into printing the famous Benchy. The Benchy is a well-known benchmark where it will test many different features of your printer, including the overhang angles, the accelerations, your attraction settings, to name just a few. You can see here, I've got 9 of them printed out, and these are just the ones which I've kept. Trust me, I've printed an awful lot more while trying to really dial in the settings for my printer. If you need any help with these, please do let me know in the comments and I'll try to help you out where I can. So now you've been able to print out a successful Benchy with no stringing and a good layer height for you. You can go into printing now a dual colour Benchy. Now the Geeetech A10m, as I previously mentioned, can print in 2 different filaments, and I like to use it for 2 different colours of PLA. Now when switching between one colour to another on Cura, you'll need to print one of these, which is known as a prime tower. What this prime tower does is when switching the colour, as it's 2 filaments going into one nozzle, there will be a slight bit of the previous colour still within the nozzle, so this needs to be extruded out. So we use the prime tower for this. So when printing, the prime tower will usually be around about here, and it will go around in a circle and it will purge out the required amount, which you will need to dial in your settings, increasing the amount in order to get a good colour mixing. If you don't do this, as you should be able to see by the Benchy which I put on the screen, you get a little bit of colour blur where the black is going into the purple on that Benchy. Let's talk about the upgrades which I've made my Geeetech A10m. The eagle-eyed amongst you will notice the red extruders on top as opposed to the plastic ones which come with the A10m as stock. This is because this being plastic, they have a bit of flex in them, causing some steps to be skipped. However, the metal ones do not have this flex, and they are dual geared, which enable better control. I would note here that once you've fitted these aluminium dual gear stepper extruders, you will need to go through and recalibrate your E-steps per millimeter for the extruders. I also have the Capricorn tubes on both extruders. This is because they are lined with Teflon, further reducing the friction when the PLA filament is being extruded through to the hot end. I have some stepper motor dampers on the extruders, the x-axis and the y-axis. This greatly reduces the vibration which travels from the extruders to the frame, reducing the noise when the printer is in operation. Finally, I have some closed loop S42B stepper motors on the x-axis and the y-axis. What these closed loop stepper motors do is have a feedback loop going back to the control module on the back of the stepper motors, which tell the stepper motors where the x and y axis should be. So if any steps are skipped, then the closed loop will recognise this and it should move where it's supposed to be at that time. In order to fit these stepper motor upgrades, on the y-axis I had to print a new bracket. The picture should be on the screen now in order to fit it in, as otherwise, with the screen protruding out the back of the stepper motor, when the y-axis is moving, it would interact with the leveling knob on the bottom. To conclude, I think that the Geeetech A10m is a very capable printer, capable of producing dual colour prints. I would note that when I was setting it up, I did find it a lot more difficult to calibrate than my previous printer, my Creality Ender 3 Pro. However, I found that once it was set up, I was able to get the same high quality prints, however with the added benefit of being able to do so in a dual colour. Remember to subscribe to our channel and look out for an upcoming video where I will be showing you the useful prints which I've been able to print with this printer.